The broadcast is now starting. All attendees are in listen-only mode.
Jani, Jeff, can you confirm that you can hear me, please? Jani, Jeff?
Sorry, Devin, I can hear you. I was on a different line.
Great, thank you. Hey, Jani. Jani, I can't hear you if you're talking. Maybe I have to make you a presenter or something? No, you're an organizer. You should be able to say hi.
He doesn't seem to have a speaker next to his name, Dev. I'm not sure why. He may, I don't know, maybe, does he have to call in? Yanni, do you have a microphone?
I'm not sure. I just made him a presenter. Maybe that will help. Jani, we can't hear you.
I wonder if when he joined, he didn't select the microphone, he selected telephone call.
I don't know, but he's organizer and presenter, so he should be able to do anything. I'm going to take him off presenter for a minute.
Yanni, can you hear us? Nod your head. So he can hear us. Well, he's got 7 minutes to figure it out, or we're gonna have to tap dance a little bit.
Yeah, Jani, are you with us yet?
Yanni, we still can't hear you, and there's still no microphone next to your name. You may need to dial in. We've only got about 5 minutes to solve this.
Jani, do you have a different computer you can try to log in from?
Yanni, 3 minutes to showtime.
Hi, everybody. Thanks for starting to join us. We will be getting underway in just a minute, hopefully on time or within a few minutes of on time. We are working through some slight hijinks with a GoToWebinar with our guest presenter today. So please bear with us as we try to troubleshoot that. Thank you very much. Give me 1 second. I'm going to see if I can get us some quick help with this. I'll be right back.
Jani, I think you're going to need to dial in. I'm sorry, and it's long distance, but we start in 1 minute, and I'm not seeing the microphone there. I don't know what else to tell you.
Hi, everybody. Thank you for signing on and joining us. Please give us just another moment. Our guest presenter today is having some slight technical difficulties hooking up to GoToWebinar. Please give us just another moment or two to get this figured out. Thanks.
Hello, can you hear me now?
Loud and
I can
clear.
hear you, Jani. Excellent. Can everybody hear Jani? Please respond in chat if you can. Jani, say hi again.
Hello, hello.
I hear you loud and clear. Let's presume that we are good to go. Jani,
Excellent.
please present the screen on your side because you'll be doing the slide control. And Devin, why don't you go ahead and start introductions?
Yes, absolutely. Jani, you are the presenter now. Folks, we've got a good house today. I'm really excited to see it. For those of you who are joining us for the first time on this particular webinar, this is actually the third of a three-part series that we were doing on data management, and we are really excited to have you all here. So in today's webinar, everybody who has been a part of all three webinars in this series has actually going to be entered into a raffle for a 4-night stay at a fantastic cabin in northern Georgia. Travel excluded, just the cabin paid for. We will be announcing that privately as opposed to blasting people's information out. So for the person who wins, please make sure you comment on our social media so everybody knows that we did give the prize out and that you are in fact happy to have received it. That would be great. But go ahead and moving forward, Jani, do you have the presenter role and your everything ready?
I think so. I hope that the voice does not circulate because I'm connected in audio from the phone. So just a second. Okay.
Excellent. So for those who don't know him, Jani is a fantastic guy. He is excels with machine learning as well as SQL, and he has put together a really great presentation on how you can combine those aspects to improve your environment. So Jani, would you like to mention anything else about yourself and your background before you jump right into the presentation here?
Yeah, why not? First of all, I'm talking today about the importance of capacity planning and cost optimization in SQL Server migrations. And here is a couple of words about myself. So slide, just adjust the window that I'm going to see what I'm going to present. Okay, so I'm founder and CTO of SQL Governor and also VP Pro Services. SQL Governor is a software company for automated capacity planning and performance optimization of SQL platforms. And today we are talking about this capacity management quite a lot. And then in addition to that, the VP Pro Services is data platform services company located in Finland. And my background is as a developer and data scientist mostly, but I'm pretty much jack of all trades, king of none in the area of SQL servers, and I have been working with SQL servers around 21 years. So that's about it. Anything to add, Devon? Okay, I think I'm good to go then. Can you still hear me?
Yes.
Very good. Okay, let's start then. So first of all, I'm going to discuss about the pain and solution, and I'm not telling you yet what is the pain here we are discussing and what's the solution. So, but first of all, one thing that often appears in any of the kind of licensing handling of SQL servers is true-ups, and quite often it kind of surprises. Okay, true-up is coming in 4 weeks, 3 months, something like that, and you need to be able to kind of act fast, especially if it's already a situation wherein you have used basically most of the licenses, and then you suddenly notice that, okay, we have to do something about it. So especially when the environment is virtualized, the good news is that you can actually make quite fast adjustments on your environment in order to be able to squeeze the kind of excessive material out from your capacity and therefore optimize the overall footprint of the licensing as well. So another thing that we are going to discuss today is tackling the data sprawl. And that's how it's done and how you're able to automate the workload consolidation. Something else, and also renewing the data center if you're getting virtualized from the hardware dominating environment. And last of the topics is transferring the workloads to the cloud. And in there, IaaS and PaaS, and especially actually we are focusing here on Azure SQL, Microsoft Azure cloud services. And then there is a little time for Q&A as well. All right. Okay, so the actual pain here is a constant change. So basically, if you're thinking about the infrastructure itself, so the networking, the storage, the physical servers, it's actually so that all the time you need to have a new hardware, you need to have a new configurations on those servers, add up RAM, CPU sockets. It's in constant move, and you have to get better storage and things like that. And you may have like dedicated storage to SAN and all that. And it's like a moving target against your growth of your capacity that is constant in all over the world right now. So another thing that is in constant change is the virtualization platform. Even though you virtualize, it's still the same kind of problems on behind. You need to understand the workloads, and even better, basically, when you are having the virtualized environment. Then what comes to software, that is also when you have a software version updates, new software coming, some software is getting old and this kind of stuff, and you need to make some adjustments on software, and all of a sudden it also affects the databases in the back. So that's one area. Then the licensing, and that's, as everybody knows, also in constant change compared to the data platform itself. Workloads are the hardest part of this all, and it kind of attaches to everything here. And it's very hard to predict. So you may have seasonal workloads, you may have non-seasonal workloads. And good news is that the great majority of all workloads is more or less quite predictable. Just imagine, for example, like a web shop or an industrial ERP system or SCM system or CRM or something like that. It's quite predictable, and there are certain patterns in the behavior of workloads based on hours, days, months, and years, and also like certain seasons, like in logistics and retail, for example. So all this is crucial when planning the capacity. You need to understand the CPU usage, which is not that simple. You need to understand not only the kind of snapshots, but the behavior over longer period of time, because there is a trend component in peaking CPU and in average CPU, and they can be very different. Average CPU can actually exceed peaking CPU component in longer term, so it's not enough just to take peaks. You also need to estimate the average component. Then there is a benchmark differences in between the CPU on source server and target server. That's part of the equation. And also, if you are going to reorganize databases within the instances, or instances within the servers, or virtual machines inside the, for all this, it goes more complex and more complex over time. When you're adding up the service breaks, and also in addition to service breaks, the maintenance breaks, the service times for the servers, you are actually having much more precise way to estimate the capacity. Because when you're maintaining the servers, it's typical that CPU is peaking on 100, but if the server all the other time is doing pretty much nothing, it makes no sense to right size the server based on those peaks, because next time you are once again right sizing against peaks, and it just grows the server need, and the real thing is that it does not need that much capacity, for example. And then there is the storage side, the IOPS, the throughput. Networks is sometimes problems in certain areas, and also in storage, in addition to latencies, throughput, IOPS, you need to also understand how the storage grows there. Okay, and all this stuff, because it's hard to predict, you typically need to bake in like 50% for your estimates of capacity, some extra. So all of a sudden the licenses also cost like 50% more. The hypothesis here is, what if we, instead of trying to manually calculate the workloads and understand then that with the basic monitoring, what if we have a capacity planning software to do all this complex stuff and make us optimal plans for the future target platform? Okay, so the solution is really the intelligent capacity planning. You're able to see your service architecture and configurations, basically the topology and this kind of stuff. The storage, virtualization, external dependencies is a plus. How the applications are bound, so how the software is bound to SQL servers and databases. Then you're able to understand the benchmark difference in between, for example, IaaS virtual machine or managed instance compared to a certain server, for example, like a Dell 940 with certain processor, for example. And then also licensing planning is important. So the software asset management team in your company should co-play with the DBAs and sysadmins. And this is, I think, important, that if you are having a bigger company, it's normally so that sysadmins take care of all the kind of software virtualization and hardware stuff. But when you're doing the capacity planning on SQL Server, it's a good idea for DBAs to help sysadmin to create as optimized platform as possible. And they're a software that is capable of for capacity planning on SQL Server side is quite optimal tool to help both sysadmins and the DBAs in this work. So cooperation is a key here. Then also in intelligent capacity planning, it's important to not only monitor but also predict these workloads, as I said earlier on. And then then you're able to cost optimize with right sizing and consolidation your workloads. And those right sizing, basically lift and shift is like you take the workloads, you take the virtual machine templates, for example, and throw them into IaaS as they are, and then you just select a certain template for them and see how it goes. So there is some challenges because you may end up having, for example, slowness in the servers. They are not right sized. You need to be able to also eliminate the possibility of having a service breaks because of not enough capacity in those templates and so forth. So the right sizing with capacity planning software is super important, and also the consolidation. So if you have consolidated your instances, your databases, you can do the same thing actually on, for example, on Azure, because on Azure there is also VMs, and you can recalculate the distribution of the instances into Azure IaaS VMs in optimal way so that they take the minimum capacity. And also if you have managed instances, you're able to redistribute the kind of long-tailed smaller instances into a one bigger managed instance, therefore make some savings. So kind of it's not all in the cloud that you just lift and shift stuff there and then you are trying to adjust those individual elements there, but it's wiser to actually adjust those elements towards the cloud before you are in the cloud. Then you get the most best performance. Also, like terms like elastic pools on Azure, on SQL, Azure SQL. So also there, certain kind of databases can be put together, work as a team in a way that if there is lots of only small footprint usage on databases and they are occasionally peaking. So these are perfect candidates to kind of consolidate under the same elastic pool. And if you're able to calculate the computational reserve in beforehand for those elastic pools, all of a sudden you're going to save a lot in these capacity calculations. So those are a few examples of how to be able to right size and consolidate your workloads. Okay, so the first thing what I'm going to cover here is the SQL Server true-ups. And for these true-ups here, first of all, the pain is that you have certain amount of SQL Server licensing, and then there is a certain capacity needed for those servers, and quite rarely they kind of meet each other. So now, actually, this is a fact that I have faced in dozens and dozens of capacity planning projects on SQL Server estates. About 80%, yeah, really 80% of all corporate servers are underutilized. So this is automatically a place to make big savings there, because underutilization level is in 50% ballpark, on my opinion, on average, which means that 80% times 50% is 40% savings around your whole SQL estate just by right sizing your environment. And then the solution for this is really that when you're doing the VM right sizing, for example, you don't need to sacrifice performance or availability. How this is possible? It's because for each VM, for example, when you're changing, taking a certain hardware server or virtual machine and transferring that to another VM or on other hosts, or when you are just right sizing the VM, you actually need to investigate certain characteristics of the workloads that I'm going to show a little later what is the most essential in VM right sizing. And when you do that in the right way, you are not sacrificing these important features of your VMs. And it's actually quite simple to go through, but the calculation process is quite complex, and therefore you need actually a software to do that. Okay, so we get back to this, how to solve it, how it looks like. When you are in a true up within the 4 weeks, 3 months, whatever, and you need to make a busy, fast solution for the right sizing of VMs. Then a bit more complicated process, more complex, I would say. So tackling the data sprawl. When you want to automate the workload consolidation, when you are a big company, like let's say 50 plus servers, maybe even thousands of servers, it's very complex task to take the candidates of databases, instances, and reorganize them into bigger hosts, bigger VMs, in a way that they are not competing to same resources at the same time. And basically, if you have too many servers to maintain, servers are typically underutilized, there is low level of consolidation, and there is high licensing costs, actually typically due to these 3 former bullet points. So the solution is here pretty much the same in a way that it was in TrueUps. So you can do highly automated consolidation planning, and that's based on mathematical method, and that's so-called bin packing problem. So bin packing problem means that it's like a Tetris game, that you have a certain workload patterns, for example, 1 hour series of data, how the, for example, CPU evolves over time for each, let's say, database or CPU time compared to instance utilization, so forth, or an approximate, or then exact number of CPU instance utilization if you are dealing with instances. And then you, with this bin packing algorithm, you're able to find out that which SQL Server instances logically are a good fit together. Instead of going like this, they go like this. They are not overlapping. So it's pretty much same ideology as basically in load balancing or in these pools, as I earlier told about the Azure SQL Elastic pools. So there is same ideology on behind, and it's not enough to take just monitored data and try to fit those monitored data series together, because you'd have to take in account the trend, how the trend component affects for next 1 year, 3 years, 5 years of data. That's super important. And basically, you can do the consolidation planning on server level, instance level, database level. Of course, database level is a bit more complex because you have to take in account the approximate of CPU time against the instance and server usage, and also the buffer pool and so forth against RAM usage on the higher level entities. But that's totally doable, and you can get good results out of that. So, and there is the savings potential that is also very, very big, around 50%. Okay. Then the next thing, if you're getting virtualized, it can be a situation where you have most of the servers are the physical servers. So kind of you're still on a most probably in a situation of data sprawl, because especially if there is lots of small footprint servers that are isolated workloads, and you want to seek the licensing gains in terms of like virtualization. For example, if you have a certain physical hardware limit there, this means also that that's the highest. You cannot scale up more than you have power on your server. So when the sockets are full, that's it. And when the RAM is at max, that's it, and so forth. So also the maintenance work is bigger when you have only physical hardware. So when you are having the virtualized environment for your SQL servers, and this is kind of first step to get better maintainable environment. So then you have more compact data platform, because you have maybe just few big host servers, and then you have virtual machines that are smaller. And when you need the higher utilization levels, you just make provisioning. You scale up those VMs, like give it more RAM, even CPU cores. You can clone the images of the VMs, and you may end up having better SLAs. You have at least more high availability possibilities to implement on the VMs than in the raw hardware-based environment. environment. And also the cloud readiness, if you think about Azure Migrate and you go into Azure, so all of a sudden you can use these virtual machine images and then pass them to cloud and configure them there. So it helps. You can do basically the same also for even the backups of the hardware, but that's not that straightforward. All right, and now we are going to this transfer to the cloud, and basically what is the main reason for the transfer to the cloud? And this is an excerpt from the Azure SQL Microsoft Docs, and the picture here, and you can see the benefit here. So it's all about CapEx versus OpEx discussion. And what comes to CapEx versus OpEx is basically that if you have a lot of capital bound to your existing data center, all the rental costs there, all the hardware costs, all the stuff that you need there to run your whole data center, that's kind of like you have to invest first, and then in the long term, your investment in a way pays off. And after a few years, your hardware gets older, you have to renew it and so forth. So it binds capital, and for growing companies, growth companies, and also the companies that are more kind of in a way stabilized, it's maybe not a good idea to have lots of capital bound to this kind of setup. So there is an option to go for pay as you go. So then your operating expenses are of course higher, but you don't need that much capital expenses. And this is because the Azure has provides you already the servers, and also the Azure provides you basically like a high availability in PaaS, platform as a service, and so forth. So there are lots of building blocks that are created already, and that makes sense. If we look at the SQL Server physical machines, raw iron, there is all the stuff, the networking, basically the hardware, the virtualization, the operating systems, middleware, and also applications. All that stuff you need to manage by your own. If you want to be able to manage more servers and more data over time, you want to go get virtualized. Then you don't need to take care of the hardware that much anymore. It's about the virtualization layer and from that above. Then you're able to scale your team's work into a bigger amount of servers. And then when you go into infrastructure as a service, for example, in Azure or AWS, so then all of a sudden you don't need even to take care of virtualization. The only thing you have to take care is there like the operating system and the images of what those SQL Server servers, for example, that you need to install there. And there are some high availability features already configurable and built in the Azure. And then when you go to PaaS, the only layer is application, basically what you need to do. And when you have a software as a service, it's just your data that you have to move there, and that's all. So it's, of course, pay as you go. You pay only the capacity you are using, only the computational needs you need. And you can even optimize that with, as I said, for example, elastic pools. So especially if you are a software as a service company. Okay, so then if we are transferring to the cloud, and what's the difference in IaaS versus PaaS? And of course the on-premises as well. So sometimes you have to keep some of the data on-premises. For example, in some industries, such as financial industry, it's quite obvious that there needs to be some data on-premises, and also if you have the legacy software, so this is very often the case. Then on IaaS side, it's one way to do the transition to cloud is to use your VM images and map them to IaaS, Hyper-V, VMware, and there are cheaper infrastructure costs in general compared to PaaS, but it has its price. There is more maintenance, so you need to kind of compare different aspects, and there exists also software to compare this kind of like total costs of and total readiness of your different servers, instances, and databases to the cloud. What else? Then the migration is faster and more straightforward typically when you go to IaaS, and you can combine IaaS and PaaS. That's very, very typical scenario as well. So you don't have to put everything in IaaS or in the PaaS. That is not often maybe the strategy that you want to follow, but the mixture of that. And then IaaS has in general better scalability than PaaS, but there are some exceptions that I go through later on. Then the workload size is really not an issue there in IaaS because you can pretty limitlessly scale up those server VM templates. And then PaaS has a built-in high availability. So in PaaS, this is super cool thing. So just imagine how complex some always-on availability group scenarios can be, wherein you have multiple replicas and do all that stuff. So that's built in PaaS. That's super cool. So the more critical your servers are, you would maybe like to put them in PaaS, but there are certain limitations that you should be aware of. I go later on to those limitations. So then you have minimized management overhead, leading to lower overall costs. And this is typically mainly for small and medium workloads. And what is a medium workload? I'm going through that in a sec. And then it also suits better to it suits for dedicated workloads. So-called instance scope features. So you either have just like a certain database instance you want to isolate and put that on PaaS. That's a good candidate for that. Or some databases you want to put in the Azure SQL database or even to Elastic Pool, especially when you are planning to create a new SaaS software, or if you want to take certain databases that are not having the same time, the busy times, and quite often they are doing nothing. So they are good candidates, as I told earlier, to this kind of Elastic Pools. Then the new software development is much better on PaaS because you don't have to do that much there to be able to get things ready, because it's most of the functionality is just built in there. And there is more optimizable hardware resource usage. As I told, the Elastic Pools on Azure SQL databases, and now it's in preview mode also in managed instances on Azure. Okay, so then what are good IaaS candidates in general when you're transferring the workloads to the cloud? Well, the production databases, if they contain 100 terabytes of data or more, except the data warehouse workload, because the data warehouse workloads basically, I would say that the hyperscale in PaaS side is the right answer for using the data warehouse workload. Then when you're having consolidated servers, and this basically means that if you have more than one instance on a server and you want to keep them together and optimize them, maybe re-optimize them in the cloud and reorganize the instances in between the servers, because all the things like storage, IOPS latencies, CPU, RAM are different. So you need to reorganize them most likely in the cloud. So for example, if you're planning that should you first consolidate your servers on-premise and then go to cloud, you may end up reorganizing them once again when you go into cloud. So it depends on case basis and has quite many variables. I have no time to cover them here, but that's what I would say is important thing to know. Then servers containing more than 80 cores or 400 gigabytes of RAM. Only on PaaS side, the Azure SQL database is an option where you can actually select up to 128 cores and 4 terabytes of RAM. And then the servers running SSRS, SSAS. So these are all things that are not running on PaaS side, except if you use Data Factory, so that can run SSIS on that side. So this is important if you want to those integration service, reporting services, analysis services still to work there. You should take them with you into IaaS. Then servers running SQL Server 2008 R2. There has been an support for that in the IaaS VMs. And if you have no interest in refactoring the related software, so that's then good idea to go just to IaaS. And don't just lift and shift, because as I said, it creates problems there in the cloud, and you have to do the kind of heavy lifting sooner or later anyway. Okay, and then transfer to the cloud PaaS candidates. So all the new database development, as I earlier said, the production database is containing less than 100 terabytes of data. And okay, there's once again, this hyperscale. I tell more about that later on. Then dedicated single instance servers are the candidates that you should put to manage instances. And then the most critical instances I would preferably do in implement in PaaS side, because if you have critical instances, you get 99.99 SLA. Actually, the 99.95% SLA that is promised was earlier promised in IaaS. The latest numbers I've seen is also 99.99 on IaaS nowadays. So there is not actually a big difference there anymore. And when you go to Azure SQL database, you get 99.995% SLAs. And then once again, if the SQL servers that are not running these integration, reporting, or analysis services, you can put there into a PaaS. All right. So then I want to show something that I promised to show. So VM right sizing in terms of what comes to a database expert. For example, if you are going to right size the usage of CPUs, as I said, you need to follow the peaking component of CPU in form of time series. You need to follow the average component of CPU, and then you need to follow the processor queue and how the processor queue behaves together with CPU usage. And this is because of the contention, and this is very important. As you can see here on this template, here we have this is actually a SQL Governor software. So what I show here. So you can select the criticality for servers, those virtual machines you want to right size, and then you're able to actually set those threshold points for example, if it's a critical server, 60% would be a great value for the peaking CPU, and 35 to 40% would be the maximum of average CPU. Those numbers shouldn't be exceeded in any point of time, or you give an SLA for them, how many times over time they can be exceeded. Then I can set how many years the prediction calculates these CPU processor queues, contents and analysis that I explain a bit later. And then if you want to include or exclude service hours, service breaks, and what's the monitor data that you want to start and end the calculation from. And then you have all the statistics, like, for example, this GovDB demo 1 had 16 cores. It should have actually 14 cores. And then, for example, SourceDB 2 has 8 cores, but it should have even 14 cores. And if you had there any kind of uptrending CPU usage, you would see it on these components of now and forecast. In this case, they are the same, so it means that it's same, or it actually goes down the trend. So that's why it's not showing the bigger numbers here. And here you can see this is the most important part. The contention is actually kind of enemy of a database big time. If your CPU queues, if your processor queues are 2 times or more the number of logical cores, at the same time when the CPU usage is 80% or more, and if this lasts for 5 minutes or longer, you will have a contention problem. This means that first your server slows down, and then when the server has slowed down, it can even halt the whole database server when the queue is big enough. So we are able also to analyze that stuff here, and that's super cool, because when you take that in count and you can say that okay, you have now 8 cores, but you need 14, so it's very good in that case. It saves you from quite of a headache. And those 5-minute intervals need to be analyzed, for example, for each hour consecutively. So if any 5-point time period is there in 1 hour more than that, it's bad thing, and you can fix it. So then the consolidation automation, that I want to also say with few words. So the SQL Governor software has the internationally patented algorithms for machine learning based algorithms to do this bin packing problem in most efficient way, so that you can have any number of source servers and instances, any number of target servers, virtual machines, or Azure VMs, for example, or even managed instances in Azure, and you say that okay, these instances go to this template. Please calculate me what is the minimum number of such managed instances or Azure, or VMs, or for example the physical hosts or Azure VMs that you need that are serving those instances in the most harmonious way, so that the performance and availability are not sacrificed based on given threshold values for the critical servers, the less critical servers, like the OS version of this and this, and then, for example, the development servers, test servers, production servers. So you can have any kind of mix and match of those servers. And here you have the results in this sample. So you can see in this sample we had 30 servers, physical servers, ended up to 7, 60 virtual machines, we need only 25. And when you're looking at the host licensing and virtual licensing cores, you end up saving over 40%, which is a super great thing. So that, and then you can see the topology, and you can drill down to storage components and see it on server, instance, and database level, even data file level, how much capacity you need for next, for example, 1 year or 3 years and so forth. So it's quite nice feature there. It's actually very unique feature. So and then the virtualization, here we can see that this is an excerpt of one of the reports in SQL Governor software. So you're able to see that you had 36 cores, and then you set your physical hosts and VMs against the target templates and template of certain server, which is Dell PowerEdge R940 with Xeon Gold 6144 processor. It has its certain benchmarks here, and operating system reserve with logical cores is 2 in this case. You can control those and how much RAM it utilizes over the instances of each SQL server and so forth. And then now you need only 32 cores. And then you can see what is the setup that was earlier for these virtual machines and what is the setup you need for these virtual machines in the longer run. And also the IOPS, throughput, latencies, all that stuff. For example, you can see that, okay, latency of 27 milliseconds estimated for the source DB2 in the longer run. That's not the ideal one. So you would like to maybe do some exercise against analyzing the storage on that particular server, and you can drill down to instance and database and so forth. All right, so that was my session here, and now if you have any questions please throw them to the chat, and I try to answer. And if there is something I cannot answer right now, depending on my knowledge or state of mind, then we are getting back to you and answer that anyway. So I can see here some questions. Okay. So one question is that isn't migrating to cloud to address most of these pain points are the best value proposition? Yeah. Of course, you can say so. So for one, if I understand this correctly, I'm not sure, but migrate to cloud address all of these pain points. Yeah, basically yes. So you can maybe you refer there to a fact that you get rid of quite of things when you get to cloud. Let's take another question that is maybe more concrete. Okay, so is there a plan soon for SQL Governor to support PostgreSQL? Very good question. PostgreSQL, I have worked with PostgreSQL in my actually in my past, and I really like it, especially the indexing is cool there. Has been like 15 years already cool indexing, but unfortunately it's not in our near roadmap here. But actually our method is applicable for that environment as well. So our patented method there. Then there is a question that what product/service you recommend guardrails for SQL Server workloads from possible ransomware? We can get back to this question. And then, okay, that's all. Any other questions? Alrighty, so this is my presentation, and here you can see my LinkedIn and info and the email where you can email me if any interest, and there is also the sales of SQL Governor and the SQL Governor website. So if you're interested, we want to of course assist you if any help needed. All right, Devon, please.
Can you hear me now?
I think you're on. Yes. Loud
Okay, good. Great. Thank you very much. Jani, I think the hardest part of those questions you answered is that each of them could be their own webinar. So I'd encourage everybody to check out Soaring Eagle's YouTube page, because a lot of those questions are answered in previous webinars, as well as the blogs posted both on the SQL Governor websites and the Soaring Eagle websites, because a lot of those questions, especially related to security and whether or not you should be on the cloud or off the cloud or somewhere in between, are way more complex than we can really answer in this kind of format. And there's a lot of education involved. So if you'd like to have that kind of discussion, Jeff or Jani and the rest of our teams would love to help you talk through that and find out what the best solution is. So please feel free to shoot us an email and let us know what you're trying to do, and we'll help make sure you get there in the right fashion. So a reminder for everybody who came to all 3 of our sessions in the first quarter, one person will be notified by tomorrow that they've won our overall prize, which is that 4-night stay in Northern Georgia, which is going to be amazing. And when you are notified, please do me a favor and jump onto our social media and let us know that you received your notification. And for all of you who have enjoyed our sessions and unfortunately did not win, go ahead and jump on our social media anyway, Facebook, LinkedIn, and just give us a shout out that you enjoyed the content we've been putting out for you guys. I hope you've all learned a lot. Jani, thank you so much for tuning in. Please go get a good night of sleep. It's kind of late over there. And we'll talk to everybody next time. Thanks.
Thank you very much. Bye-bye.